Dear all, I would like to welcome you all in the lecture series of training on competitive examination. In this session, I have prepared some important equation in the area of power system. So first we'll discuss about the generation part. So there are few definitions like load factor. What is the definition of load factor? Average load by maximum demand. Then you can see the definition of the demand factor. So what is the definition of demand factor? Maximum demand divided by connected load. If I talk about the diversity factor, sum of individual maximum demand divided by maximum demand of entire group. Remember, load factor will always less than 1, where diversity factor will always greater than 1. So like that, you have to remember the important equation. Let me continue. Next is utilization factor. What is utilization factor? So you need to take the ratio between maximum generator demand divided by generator capacity. Then you will get the utilization factor. Similarly, another important term called planned utilization factor. Actual energy produced upon the maximum possible energy that could have been produced. That is called a planned capacity factor. Okay. So kindly note down this important equation. You may get in terms of numerical example or in terms of definition. Now, there is another important equation called the power factor improvement. Like leading kVAR supplied by the power factor correction equipment. There is a derivation. The result will be kilowatts into tan phi 1 minus tan phi 2. This important equation also you have to remember. Next, I would like to discuss some equations from transmission and distribution. In that, string efficiency is very important. So whenever you are placing the insulators, how to calculate the string efficiency? So voltage across the whole string you have to calculate. That should be divided by the total number of insulators disc you are used. That should be multiplied with the voltage across the lowest unit connected to the line conductor. So this is a formula for calculating the string efficiency. So this point you have to remember. Similarly, surge impedance, or you can call it as a neutral impedance. If you use any of the formula, you can use. Suppose if inductance and capacitance are given directly, ZC can be calculated by using the ratio of square root of L by C. For if the admittance, shunt admittance and series impedance are directly given, use the formula. ZC is equal to square root of Y by Z. Okay, so this is very important. Kindly make a note of this. Similarly, overhead line, the surge impedance varies from 400 to 600 ohm, where underground cable, the surge impedance varies from 4 to 60 ohm. Okay, surge impedance is more in case of overhead line. Another important term called sag. So we have derived an expression. Sag is equal to S is equal to WL square divided by 80. L is the length of span, W is the weight per unit length of the conductor, T is the tension of the conductor. That is very important. S is equal to WL square by 80. All right. Next is per unit value. Actual value by base value. The importance of per unit value is also very important. What is per unit value? Similarly, one numerical example you can expect using the formula. So per unit value, new value can be calculated by using the formula. PU old should be multiplied with KV old by KV new the whole square into MVA new by MVA old the whole square. So this is very, very important. So kindly make a note of this. Now, equation of real power output of generator. P is equal to magnitude of E into magnitude of P by XT into sine delta. Similarly, reactive power, you can use this formula. Okay, real and reactive power. Make a note of this. Now you can calculate the insulation resistance. How to calculate the insulation resistance? R is equal to rho by 2 pi L into log of R by R. So capital R is the conductor radius, R is the small letter R is the sheet radius, where rho is the resistivity. Similarly, one more formula you can use in terms of leakage current. Supply voltage by leakage current is nothing but insulation resistance. Okay. Now, when you are talking about the line capacitance, you can use the below formula. The line capacitance, you can calculate it or by using the formula 2 pi epsilon 0 epsilon R into the internal radius R divided by log capital R by small letter r. So this is also very important. Similarly, in power system protection, so you must have familiar one equation of plug setting multiplier, PSM. Okay, fault current by current settings into secondary CT current rating into the current transformer ratio, CT ratio. This is very important. Similarly, time setting multiplier, you can use the formula T required divided by T. Okay, so this is also very important for your competitive examination point of view. Then there is one ratio, TMS and the operating time. Similarly, the Stefan's law of radiation, which will be really helpful for deciding the heating element. So you have to focus on the total amount of heat which is generated from the coil using the Stefan's law of heat radiation. So it will be helpful for designing a particular coil. Similarly, dielectric loss you can calculate by using the formula 2 pi f into C into V square into delta. They may ask that what are the factors which are affecting the dielectric loss? 2 pi f CV square into delta. So this is regarding the dielectric loss. So these are the various equations which will be helpful for your competitive examination in the area of power system. So I'll be coming up different equations in the coming video. Thank you so much for watching this video. Before going to the examination, I request you to go through once. Definitely, you can recall at the time of examination. So wish you all the best. Thank you.